Again, a warm welcome to all of you. We are going to start our first session today as 1 week faculty development program on artificial intelligence driven technology and VLSI IC design for IT applications. FDP can help faculty members learn about technological advancements and integrate them into their teaching. It is a culture of continuous improvement and innovation in teaching. For this innovation, we have today the expert speaker, distinguished speaker, Dr. Smith, Professor Ibrahim. I just want to introduce our expert speaker to all of you. Professor Dev Sorosar is a professor in the Department of Electronics and Communication Engineering at IIT Delhi. He brings over 16 years of experience in the semiconductor industry, having worked with leading organizations such as Cadence Design Systems in India and Magma Design Automation. His research interests span VLSI design and automation, electronics, and energy efficient systems. His highly popular NPTEL course VLSI Design Flow RK to GDS has attracted over 24,000 participants in the past 2 years. Professor Saurabh is also the author of the widely acclaimed book Introduction to VLSI Design Flow, published by Cambridge University Press. This first of its kind book provides comprehensive coverage for the entire VLSI design flow. Served as an editor of IET Technical Review and an associate editor of IEEE Access in recognition of his contribution to VLSI education nationwide. He received the Outstanding Educator Award 2020. What excellent of you, sir. Give a round of applause to Dr. Saurabh, sir. I just request you give a round of applause to our wonderful speaker with us. Sir is going to speak about smart design, smart algorithms, machine learning, electronics, design, automation. Thank you, sir. I'm inviting you for the presentation.
Thank you very much. Good morning, everyone. Hope I'm audible to all, right? Okay. So, the topic that I will be taking today is smart design with smart algorithms, right? And what do we mean by smart design, right? That is the first question. So smart design, by the term design, what I want to say is that design should be of good quality, right? That is what the smartness is. It can be in terms of various figures of merit, right? For example, area, power, timing, and many other things, right? So the figures of merit will be good, will be better than traditional designs, and that's why we call it a smart design. And the second part is smart algorithms, right? So by smart algorithms, we what I want to say here is that the algorithms which are different from the traditional algorithms, specifically the algorithms which are related to machine learning and artificial intelligence, right? So this is the basic premise of this FDP, right? So we will be looking into the how to use the smart algorithms, which are mostly directed towards machine learning and artificial intelligence, and how we can use it or utilize it to derive smart designs, right, or better designs, right? So this is the basic idea of this FDP, right? So I would like to make this session interactive, right? Rather than me speaking all the time, I will want that the speaker, the participants also talk, ask questions, and try to utilize this opportunity to the best we can, right? So depending on your interaction and what questions you have, I will try to take this FDP or session to be more productive, right? So please try to be interactive and try to ask questions. If you are not following, please ask, and therefore I can try to explain it, and we can make it more useful, right? So that is the premise of, that is what we I want to achieve in this FDP, right? So this is the outline of the presentation. So I'll be discussing introduction to EDA tool flow, then the motivation of using ML or machine learning in EDA tools, and then the key areas of ML applications, in the EDA tools, and then we'll be looking into the ML techniques commonly used in EDA, and then we'll be looking to at a few case studies, then challenges, and final takeaways. Right. So this is the broad outline of what I have in this presentation, and depending on your questions and what how you want it to be make it more useful, we can take different routes, right, depending on what the current understanding you have about the machine learning or EDA tools. I will try to modulate this lecture to make it more useful, right? So first, let us understand the EDA flow or EDA tool flow, because what we are in this FTP, what we are trying to do is basically utilizing machine learning for EDA tools, right? Now, how many of you basically know what is an EDA tool? Can you just raise your hand? What is an EDA tool? So, how many of you know or have used any EDA tool? Right? EDA stands for Electronic Design Automation. These are tools which are used to design circuits, systems, and other. So, how many of you have actually used any EDA tool in your curriculum or your? You have not used any tool? No. No. Okay. So no problem. So I'll probably try to first explain what is EDA tools, and then probably take it to machine learning, because just explaining that what the machine learning will, or how we use machine learning for EDA may not be that much useful, right? So um, let me introduce what are EDA tools, what is EDA tool flow, and then we'll go deeper into it, right? Now, electronic design is a complicated process, right? So uh, I know everyone knows what is a chip, right? Yes. Do you know what is a chip? The students in that room, you know what is a chip? What is VLSI? Right? You know at least this much. Right? Now, everyone has a mobile, right? Mobile might have some processor. What is your estimate that how many transistors that processor has? Yes, any idea? How many how many transistors that your processor might be having? Any rough idea? 1 to 10 billion. Yeah, it will be in some million or billions, right? So depending on the complexity, it will be millions of kids, right? So the VLSI system that we are designing is a very complicated. Now, how do we design this complicated? Now, how do we design this complicated chip, right? You have and the transistors, and in the chip you have millions of transistors. Now think from the perspective of a designer, how a designer will design this chip which has got 1 million transistors. Of course, the designer cannot do it manually, right? Because the number is too large, and a designer needs to take help of various kinds of tools. So these tools are basically known as EDA tools, right? So in the designing process, what we do is that we have some idea of a product or a chip, and based on that, what the idea is, finally we want to get the layout